A system of equations using elimination, the equations must be in standard form. The goal of this method is to eliminate or get rid of one of the variables so that we can solve for the other variable. We do this by adding terms with opposite coefficients. If your equations do not have opposite coefficients, you must multiply one or both of the equations by a constant to create opposite coefficients. You'll notice that in this first example we have two coefficients of terms that are opposites. We have 6x and negative 6x. So if we were to add these two equations right now, 6x plus a negative 6x cancels out to 0. Now we can add the rest. Negative 12y minus 36y is negative 48y. 24 plus 24 is 48. The result of adding the two equations is the equation with one variable, and it only takes one step to solve. Divide both sides by negative 48, and you'll get y equals negative 1. So the solution to this system, right now, we have our y value as negative 1. We still need to find our x value. So in order to find our x value, we need to take our y value and plug it back into one of the equations. It does not matter which one you choose, of course. I'm going to choose the top one. So 6x minus 12, and instead of y, I'm going to write negative 1, equals 24. In order to solve for x, we're going to do negative 12 times negative 1 to get positive 12. From here, solve for x. Subtract 12 from both sides. That's now 0. 6x equals 24 minus 12 is 12. Then divide both sides by 6. X is going to equal 2. So our solution right now is 2, negative 1. Our x value is 2, our y value is negative 1. This represents where the two lines cross on a graph. In order to check your answer, plug in both the x and y into both equations. So for the first equation, you have 6 times x, which is 2, minus 12 times y, which is negative 1, equals 24. 6 times 2 is 12. Negative 12 times negative 1 is 12. And 12 plus 12 is 24. So that checks out. To try the second equation, we have negative 6x minus 36y equals 24. So instead of x, I'm going to write 2. Instead of y, I'm going to write negative 1. Let's see if this checks out. Negative 6 times 2 is negative 12. Negative 36 times negative 1 is a positive 36. Negative 12 plus 36 is 24, so this also checks out. So this solution is correct. As I mentioned earlier, in order to eliminate, you must have two terms that have opposite coefficients. In this example, number 2, our x values, or x terms, have coefficients that are not opposites. We have a 6 and a negative 8. Those will not cancel out to 0. Our y values have negative 10 and 5. Those will not cancel out to 0 either. So we're going to multiply one of these equations by some constant to create opposite coefficients. The easiest way to do this is to look at the coefficients of each variable. If I have 6 and 8, 6 is not a factor of 8. So I would have to multiply both equations by some constant. Over here for the y coefficients, I have 5 and 10. 5 is a factor of 10. So if I multiply the bottom equation by 2, I will create a y term that is the opposite of negative 10. Because 2 times 5 is positive 10. So I'm going to rewrite the first equation. Negative 8x minus 10y equals 24. And then I'm going to write the new equation beneath it. So 2 times 6x is 12x. 2 times 5y is 10y. And you'll notice right now I have negative 10y and 10y, and those are going to cancel out when I add these two equations together. 2 times 2 is 4. So when I add these together, negative 10y and positive 10y will cancel out to 0. So I'm just going to go ahead and just draw a squiggly over there to show you that that's now 0. Negative 8x plus 12y, negative 8x plus 12x is 4x. 24 plus 4 is 28. This is a one step, divide both sides by 4, and x is going to be equal to 7. So right now my solution, I only have the x coordinate, the 7. In order to find the y, I need to plug x back into one of the equations. It does not matter which one of the three types that you have, just choose one. I'm going to choose this top one here. But again, it's arbitrary. You can choose any one you want. Plug in 7 for x. Negative 8 times 7 minus 10y equals 24. Negative 8 times 7 is negative 56 minus 10y equals 24. Solve for y. Add 56 to both sides. You have negative 10y equals 80. Then divide both sides by negative 10. Y should equal 80 divided by negative 10 is negative 8. So my solution right now is 7 comma negative 8. This is the point at which these two lines cross. Again, to check our answers, plug x and y back into each equation. So in the first equation, negative 8, instead of x I'm going to write 7, minus 10 times y, instead of y I'm going to write negative 8, equals 24. It's going to be negative 56. Negative 10 times negative 8 is going to be positive 80, equals 24. Negative 56 plus 80 is 24, and that checks out. Let's check the bottom equation now. So instead of writing x, I'm going to write 7 again. So 6 times 7 plus 5 times y, which is negative 8, equals 2. 6 times 7 is 42. 5 times negative 8 is 40. So 42 minus 40 is 2. So that also checks out. So our solution of 7, negative 8 is correct. The third example of these elimination problems shows something a little bit different from the first two. If you look at the two equations, the x terms, you have 4 and 11. 4 is not a factor of 11. I cannot multiply 4 by some integer and get 11. Same thing with 5 and 9. 5 is not a factor of 9. So we come to two equations that have coefficients of terms that are not factors of each other. So this is the case where you have to multiply both equations by some constant. And in this case, it doesn't matter whether you choose the x's or the y's to cancel out, because it's going to be just as much work for either. But you should note that both terms have positive coefficients, and when we cancel things out, we need to have a positive coefficient and a negative coefficient. They need to be opposite. So when we're multiplying both equations by some number, one of those numbers should be negative. So we have opposite signs to cancel out. I'm going to choose to cancel out the x's, and this is a lot like adding two fractions together to find the least common denominator. Here we're going to find the least common multiple of 4 and 11, and that's 44. 4 times 11. So we're going to multiply the top equation by 11. I apologize. We're going to make the top number we multiply by positive. So it's going to be positive 11 we're going to multiply by. And we're going to multiply the bottom equation by a negative 4. Because we want the signs to be opposite. I'm going to rewrite the top equation. 11 times 4x is 44x. 11 times 5y is going to be plus 55y. 9 times 11 is 99. Second equation, copy down here. Negative 4 times 11x is going to be negative 44x. And you'll notice that we have those two terms that will cancel out now. Negative 4 times 9y is going to be negative 36y. Negative 4 times 20 is going to be negative 80. So right now I've created two equations that will have two terms that cancel out. So it's slightly more work than the first two examples, but the same method applies. Add these two equations together. The x is going to cancel out. 55y plus a negative 36y is going to be 19y, positive. 99 plus a negative 80 is going to be a positive 19. So from those two equations, I have this one equation with one variable, with one step to solve. Divide both sides by 19. Y equals 1. So my solution right now, I have just the y value of 1. The point at which these two lines cross. The y coordinate is going to be 1. In order to find x, we're going to plug it back into one of the equations. Now I have 4 here. It does not matter which one you choose at all. So I'm going to choose just the first one and plug in 1 for y. So 4x plus 5 times 1 equals 9. 5 times 1 is 5. From here, it's just a two-step equation. Subtract 5 from both sides. 4x equals 9 minus 5 is 4. Those being 0 now. Divide both sides by 4. X equals 1. So 1 comma 1 right now is our solution. But remember, we should check to be sure that it is our solution. So each equation, plug it in. Plug in 1 comma 1. So the first equation, 4 times 1 plus 5 times 1 equals 9. That's going to be 4 plus 5 equals 9. 4 times 1 is 4. 5 times 1 is 5. 4 plus 5 is 9, so that first equation it checks out with. It must check out with both, though. So we're going to check the second equation. 11 times x, which is 1, plus 9 times y, which is 1 as well, equals 20. 11 times 1 is 11. 9 times 1 is 9. 11 plus 9 is 20. So this solution checks out as well. So the solution to the system is 1 comma 1. And remember, this represents where the two lines cross at on a graph.